In this video, we're going to go farther than we have before with the number patterns. And the first thing I'm going to do is try to grab something on page or on the homework. All right, here's a sequence. Let's take a look at this specific one. Here is called an arithmetic sequence. That's because to get each term, you add the same amount to get the next term. So if I take 8 and I add 8 to it, I'll get 16. But then if I take 16 and add 8 to it, I'll get 24. So you can see you're generating the terms of the sequence as you go. 24 plus 8 will be 32. 32 plus 8 will be 40. What is the next term of that sequence? Well, it'll be 40 plus 8 will be 48. And to get each subsequent term, you just keep adding 8 to them. So any kind of a sequence where you add the same amount to get the next number each time is known as an arithmetic sequence. In this example, we have what's known as a geometric sequence. Here, we multiply the same amount to each number to get the next number. So if you look, if I take 2 times 6, I'll get 12. If I then take 12 times 6, I'll get the next term, which is 72. If I take 72 times 6, I'll get 432. If I take 432 times 6, I'll get 2592. And if I want to know the next term, I'll take 2592 and I'll multiply it by 6. $15,552. Now each of the sequences I've done so far should be easy to recognize. It's very easy to test whether they're arithmetic or geometric. We're going to look at some more complicated ones than those two. Now, this is an interesting sequence. Believe it or not, this sequence is still geometric, because if I take 4096 and I multiply it by 0.25, I'll get 1024. Then if I take 1024 times 0.25, I'll get 256. 256 times 0.25 equals 64. 64 times 0.25 equals 16. And then if I want the next number, 16 times 0.25, that will equal 4. And you can keep going. 4 times 0.25 equals 1. And if it decided to keep going, then we'd have 1 times 0.25 would equal 0.25. If I wanted to go again, 0.25 times 0.25, that equals 0.0625. And you can keep going and generating them at will. What we're going to look at next is a type of sequence that is neither arithmetic or geometric. By the way, your textbook, as you're reading through it, they'll talk about a common ratio. And that common ratio is exactly the thing I kept multiplying by the same amount every time. So for this next one, let's determine the next most probable number. So determine And the sequence I have is 2, then 6, then 22, then 56, and then 114. Now if you look, when I do go from 2 to 6, I would add 4. If I tried to add 4 again, 6 plus 4 is only 10. That's not going to work. So the sequence is not arithmetic. However, if I try to do geometric, then to go from 2 to 6, I would have had to multiply by 3. But unfortunately, 6 times 3 is 18. So this sequence is neither arithmetic or geometric. We have to come up with some other way of figuring out what the next number is. So there's a method here called the method of successive differences. And let's see how it is used on a problem like this. So first thing you're going to want to do is spread out your terms because you're going to need some space. What I'm going to do then is take a look at the differences between a term and the subsequent term. So like for 2 and 6, if I look at that, 6 minus 2 is equal to 4. The difference there is 4. And then let me do it for these two. 22 minus 6 is 16. 56 minus 22 is 34. 114 minus 56 is 58. Now, what I'm going to do is do the same thing again, but I'm going to do it like a second line. So I'm going to do this. 16 minus 4 is 12. 34 minus 16 is 18. 58 minus 34 is 24. Now at this stage you should see that we have a sequence that's working. I see that if I look at just this last row here, it goes 12, 18, 24. It's an arithmetic sequence. That means that in this problem here, I am trying to figure out the number that comes next. So remember, it would have been made up of this and this. But then I would have had a spot here that I would have had to fill in, this and this. And I think I'm able to now. Watch. If I know the next amount is going to be 30, now if I work backwards, 58 plus 30 is 88. And then if I take 114 plus 88, I end up with 204, and that's the number that I'm looking for. Now on this last row here, you could see it was an easily discernible pattern, and that's as far as you ever need to go if you need to get anywhere. Let me check something for a minute. I think I've made a mistake right here. There it was. This is a 32. That changes this. And you can see any mistake that you make has massive implications. And the 204 is still right because I copied it from my notes. Now, if you need to, you don't have to stop at this last line, especially if it doesn't look like it's anything that you can recognize yet. You can go one more line and you'll always end up with something like this. That way, if I needed to get a new number here, I could have done that. And then I would have had a number here, which would have been 38. And then I could have built numbers from there on after. So only do as far as you need to go until a pattern emerges that you can obviously see. Alright, so the direction's the same as before. We want to come up with what is most likely the next number after 118. So I'm going to do the same thing I did before. I'm going to give myself some space, and I'm going to write them out. Let's see, we're going to have our 3, 14, 31, 54, 83, 118, and the one we want comes after the 118. So I'll put a little spot there waiting for it. So now let me start doing the differences. So if I look at 14 minus 3, I get 11. 31 minus 14 is 17. 54 minus 31 is 23. It looks to me like it's pretty evident what's going on here. It looks like I'm adding 6 every single time. Here, let's check the next one. 83 minus 54 indeed is 29. So then the next one should be 35, and it is, and the next one after that should be 41. And that means if I take 118 plus 41, I end up with 159. Now once again, let me reiterate, you don't have to be that sharp right now. If you want to, you can keep going, and whenever you get to a line that has all of the same number, then you know you're gone as far as you can. Okay, once again, let's find the next most probable number. So let me put my numbers out here. I got a 1, 11, 35, 79, 149, 251, and then the number that I want to get. So let's start. 11 minus 1 is 10. 35 minus 11 is 24. 79 minus 35 is 44. 149 minus 79 is 70. And then 251 minus 149 is 102. One thing I do for myself to kind of figure out how much I need to go yet, I'll kind of keep blank spots that I don't know, and then I'll fill them in it when I get some more information later. Right now, it doesn't look to me like I can see any kind of a pattern emerging from the numbers in the second row. So let me do the process again. I'll have 14, 20, 26, 32. Indeed, I see the pattern now because the bottom row now is going by sixes again. That means this one should be 38, which means that this should be 140. 102 plus 38 is 140. And then 251 plus 140 is 391. As my last example of the method, I'm going to pick the nastiest one I could possibly find out of your textbook. So I'm going to need a lot of space. I'm going to put my 3 all the way over there, and my 19, 165, 771, 2503, 6483, 14,409, and then a blank spot. Alright, let's start doing our subtractions. 19 minus 3 is equal to 16. 165 minus 19 is 146. And then you'll probably very quickly get to the point where a calculator is needed, so I'm going to grab mine right now. Here, it actually looks like I'm adding 120 every single time. I'm going to do one more line to make sure. Well, you'll be able to see if you do the subtractions here. So I needed this spot here, plus I need this spot. Well, I now know it's 120. Now work your way up by adding. So the 576 plus 120 will be 696. And the 1698 plus 696 is what I want next. So that one there is 2394. So I'll take the 3946 plus the 2394, and I get 6340 for my next blank. I'm working my way up. I only got 2 more blanks left. 7926 plus 6340, and enter. 14266, and then to get my final answer I got to take this 14266 and add 14,409 to it. Now, one thing I notice, I'm not being as efficient as I can. If I just hit add, it'll bring my answer back, and then I can put the 14409, enter. So I get the final number, 28,675. And that, of course, is the most probable next number. So you see, you can run the successive differences as far as you need to go. Here's the last example I'm going to do, but it's a completely different example than I've done before. So this time I'm going to add 1 plus 3 plus 5 plus, and I'm going to only add up odd numbers all the way till 49. So I would like to know what are the sum of those numbers. There's a formula for this. If n is odd, then when I add 1 plus 3 plus 5 plus ... plus n, so it's all odd numbers up to n, the formula is this: n plus 1 divided by 2 squared. Now, if you go to the textbook and try to use their formula, it looks a little bit different than mine, but they are exactly the same formula. So for the problem that we have, the n is equal to 49. So when I try to do 1 plus 3 plus 5 and I add all the way up to n, 49 that is. So I have 49 plus 1 divided by 2 squared. And that will equal 50 over 2 squared. And that will then equal 25 squared, which is equal to 625.